All right, question number 5. Question number 5 is the application of a differential equations and the derivative and the integration, you can say. Okay, so the question 5 says, in the figure 3 shows a container in the shape of a hollow inverted right circular cone. The height of a cone is 30 centimeters and the radius of the cone is 12 centimeters as shown in the picture. The container is initially empty when the water starts flowing into it. When the height of the water is h centimeter, the surface of the water has a radius of r centimeter. It's talking about a small container, a small inverted right circular cone down below here, and the volume of the water in that, when the water started flowing into this container, after a while, when the time passes, the volume, the amount of water inside the container increases. So it's basically, that is denoted by V centimeter cube, so basically the V. So we need to show that the volume of the this small circular cone right here, which is the amount of water that flow into container, is a 4 pi h cube over 75. And just a little bit of explanation, and it gives us the formula, that the way we calculate the volume of the circular cone. Okay, so the thing is, we don't actually do, there are two topics we are going to use. Like the one way that we just like finding the volume of the cone, which we are happy about it because they gave us a formula. And the second way to do so, to show this, we are going to use the topic similarity. We don't actually do this similarity on ASA level, but we have done this in IGCSE. So that's the thing here, like you're going to be using the knowledge you have gained on the IGCSE and then AS, and then you put them all together in A level, like pure mathematics 4, and you solve the question on that. All right. So I'm going to be doing this question in a few steps, like let me call this a step number 1. And in the step number 1, if I'm trying to find let's say the volume of the circular cone over here, the smaller one, so I need to be just applying the formula, which is V equals to 1/3 pi r squared, area of the cross section, times the height. So the r is r, the height is height in the smaller cone you can see over here. All right, that's good. And if you look at the formula that you are trying to prove, you see that the V is only equals to something in terms of h, so there is no r in the formula. I mean, there is no r in over here, so we need to get rid of this r. We need to converting that r into something in terms of the h. As you can see, the final form is only 4 pi height cube divided by 75. So basically, what I need to do, I need to have created proportion or a relation between height and r, the radius of the cone with the height of the cone, so I can basically replace radius in my formula right here with the height instead of r, right? There's something in terms of height, and then I solve it. Okay, so that's the second step I'm going to be writing here. In the second step, like by the way, the first step is just the formula I wrote, and I realized, oh, like I need to take this radius in terms of height, because that's what I want to show. Okay. In the second step, let's say I'm going to be using the rule in similarity in the shapes. Okay. That's the topic you did in IGCSE. If you are doing an A level, you presumably had a really good result, really good score in an IGCSE, because an A level requires a good results from that. So if you just basically apply the simple similarity formula or a rule, let's say. So if you look at this cone, there are two like cones here, like you can see. We have a larger cone with the height 30 and 12, and we have a smaller cone with the height h and the radius r. So according to the similarity rule, if I divide the corresponding sides or the corresponding lengths of these shapes, they're going to be equal, right? So I can say that the radius of the smaller cone divided by the radius of the larger cone, I can write this because they are similar. They must be similar. Because the top part, which we actually call the top part of this, the cutted piece, let's say, imagine that you're cutting this piece, you left over the truncated part. So this part is called the apex. Like the apex of this like cone is cut off, and then you left with the truncated cone. Like this is truncated cone. You did this by the way in JCC also, truncated prism and etc. So so that's only done with like the part is cut out, like leaves us the similarity. Okay. All right. So that's equals to. And radius divided by r divided by 12, that's equals to, so I can write the same rule with the height, so that's also the corresponding, let's say, the length, height of the smaller divided by the height of the larger cone. Okay, so remember I need to follow the order. If I start dividing the radius of the smaller cone by the large, I need to keep doing the smaller over larger, smaller over larger. I cannot, let's say, I should be following the pattern. That's what I want to say. Okay. All right. So remember what we are trying to do. We are trying to write a radius in terms of height. So I'm gonna make it a radius the subject. So I'll just like multiply both sides by 12. So that's gonna be 12 height divided by 30. So simplify by 6. That's a 2 height divided by 5. Okay. So I'm going to go back to step number 1 because that's where I've had a formula, and instead of the radius I'm going to be writing 2 height divided by 5. So that's 1/3 pi multiplied by radius, which is a 2 height divided by 5, radius squared. Okay, so that's the height. So all I have to do is just expand this, square it, like that's going to be 4 pi, yeah, so I mean 4 height squared divided by 25 height. So just multiply everything, so that is going to be 4 pi height cubed divided by 75, and that's what we show. This is how we show, and that's pretty much it. Okay. Alright, so the next step, next question, next part is given that the water flows into the container at the constant rate of 2 pi centimeter cube per second. So that's the volume, rate of the volume is basically by the time passes, that's the amount of water flows into a container. So that's a change with respect to time. That's just a change of the amount of water in the container with respect to time. So dV, that's the volume, divided by dt, that's going to be equals to 2 pi. Remember, there can be two types of change. There can be negative changes when there might be a leaking in the container, but this time there's no leaking, just a flows into a container at this rate, and the amount of water in the container increases. So that's going to be just a positive 2 pi, like every time it increases, every second the amount of water in the container increase by that. So centimeter cubed per second, like second to the power of -1, or just like a slash in between. Anyway. Alright, so what we are asked to do is find in centimeter per second the rate at which height is changing exactly 15 minutes after water starts flowing into a container. So after 15 minutes, we need to find the change of the height, like how it changed after 15 minutes. So basically, it's better to write, let's say, dH over dt. That is the change of the height by the time passes. Why do I need to write this? So firstly, that tells me what I'm looking for to find, and this, how do I know this is like you just basically clearly see this from the context itself, the question itself. Or if you look at this centimeter per second, that also unit tells us, if you're doing a physics, unit tells us what changes with respect to what, like centimeter lengths. They especially mention the height with respect to second, like time is the second. Anyway, okay, so we're gonna be doing like a few things here. First thing that I'm gonna do, let me say the step number 1. I'm going to be writing this d height dh over dt, like a dh over dt is I'm going to be using a chain rule. Okay, so you did the chain rule topic, and you know that the height right now is like a real life situation that we call it the application of the real life, right? So height is changing with respect to time. Okay, so because the water flows into a container, and by the time passes, the height of the water in the container increases. So that's something like naturally we can think logically, and the volume also changes by the height changes. Like if the height changes, volume changes. You can see the formula: 4 pi height cube divided by 7. They're directly proportional, but cube of it, like they're like a cubic effect they have. Volume height has on the volume, let's say, and as well as volume changes by the time passes. Okay, so the volume depends on time and as well as the height. So that's basically the little chain rule. Okay, 2 variables, like we have height depends on the volume, time, let's say volume depends on time also. Okay, as well as the height. Anyway, so I can write this one as dv over, I can write this one as a dv over dt. Okay, so that's the change in the volume with respect to time, and that's multiplied by that's my bad, actually I need to be doing this as actually other way around. Let's say it's going to become the same conclusion. So let me write this in this way. It's being more clear. dv over d height. It's like the time changes, like we did for example, dy over dx, the chain rule. Okay. So let me just write this more clear in this way. And then that's going to be dv over dt, where we had over here dy over dt, and multiplied by dt over d height. So basically the first thing that I was writing the same way, but when you write it the other way around, it feels like a bit weird. Like that makes more sense, I believe. So on that the formula, on the chain rule, we said the dt over dx. So basically what is this is, in the chain rule, if you simplify dt by the dt, so you're gonna be ending it with dv over dh. All right. Okay, so which is the same as the left side. So we are looking for dh over dt over dh. Actually, we are looking for dh over dt. So I can make the dt over dh the subject of this formula by dividing both sides dv over dt. Okay. So first I'm gonna do is the dt over dh is the same as the dv over dh divided by dv over dt. So that is giving us dv over dh multiplied by dt over dv. Okay, so I'm going to be reversing the final answer that at the end when I get it, is because I am looking for dh over dt, but so far I'm going to be working on that. Okay, so and then I just put everything that I know so far in sort of the expression. So I know that dv over dh, so I can work this out from the previous formula or an expression right here. Let me actually do this somewhere here. So the dv over dh is the derivative of volume with respect to the height. That is going to be 12 pi height squared divided by 75. So you can simplify this by 3 or whatever. I'm gonna be keeping like this. I don't have a space to do that. So basically I found the derivative of the volume. Okay, so I'm gonna be writing that right here. It's gonna be 12 pi height squared divided by 75, and that is going to be times dt over dv. So dt over dv is the given over here, that the vice versa of this, like we have given as dv over dt, but I can write this as 1 over 2 pi, which is the reverse of the dv over dt. Okay, so then I can simplify pi and pi, and let's say 2 and 12. So I'm going to be ending up with the 6 height squared divided by 75. So that's not the end yet, because right now what I ended up with is the height 6 height squared divided by 75, but they want us an exact value at this 1.5 minutes after the water flows into a container. Okay. To do this, so I'm going to be using the given expression right on the top. Let me write this as step number 2, then I'm going to come back to the step number after finding the height. Okay, step number 1. So I'm going to be solving the differential equation, finding v in terms of t. So that gives us dv is equals to 2 pi dt. Take the integral of both sides, so integral of dv, that's equals to integral of 2 pi dt, so the right side with respect to v, the left side with respect to t. So that gives us v is equals to 2 pi, that is going to be just a t plus c, which there's a constant. Okay, so now I need to know what is the constant. It's actually a 0. How do I know that? I'm going to go all the way back to the question. They say over here the container is initially empty when the water starts flowing into it. Okay, so which means by the time 0, like if basically the time is 0, like time 0, that like starts time. Okay, so the volume was 0, like. Okay, so which means 0 is equals to 2 pi times 0 plus c, that gives us the c is equals to 0. So that means the volume is just the 2 pi t. Okay, so what I'm going to be doing now is, they say after 1.5 minutes, remember the rate of change is per second, so that they give us a minute. I need to convert the minute into second. I'm going to be saying that's a 2 pi multiplied by 1.5 times 60, converting that into a second. So I'm going to be multiply 2 by 1.5 and times by 60. That gives us 180 pi. Now, why I'm doing this? If you remember, I told you I need to know the height. That's going to help me to find the height. I found the one formula for the v as 180 pi. Another formula for the v, the volume, is given 4 pi h cubed divided by 75. 4 pi h cubed divided by 75. So I'm going to be equalizing this to find the h. So that's 75. So if I solve this equation, I'm going to be finding h as 15. I solved this before. I know the answer. I don't want to make the video super longer. Okay, so what I need to do, I need to come back here now and multiply 6 by 15 squared divided by 75. So if just I calculate this, that's going to be 6 times 15 squared, and that is divided by 75. Okay, so that gives me 18. But remember, 18 is not your answer. So if you did all the way back there, that you are basically have probably like the 3 marks, or maybe the 4 marks. You need to look at the mark scheme. But don't forget that what you found over here is dt over dh. So you are looking for to find dh over dt. So that is going to be 1 over 18, just a reciprocal of that, centimeter per second, or you can write it as second to the power of -1. So that's going to be your final answer.